This video is brought to you by Amber. Amber keeps your EV on the road longer, offering seamless protection with no long-term contracts or upfront costs. Learn more at the link in the description and use code SPEC5 for 5% off. Howdy folks, welcome back to another Out of Spec Renew video. Today we're working on this 2011 Nissan LEAF. It's got a pre-charging issue, which means that it can't actually pre-charge the high voltage system and close the main contactors. So in its current state, it's undrivable. But anyway, let's go ahead and dig into the cause of this issue, and we'll figure out a fix for it. So full disclosure on this car is that I actually previously did some diagnostic work, actually probably about a month ago off camera. And the customer ultimately ended up deciding that they didn't want to go forward with doing the work on the car, so I actually agreed to purchase it from them. So I'm actually the owner of this car, and yeah, we're going to go ahead and get into just sort of an overview of what I did diagnostic-wise. I'll kind of give you guys a quick peek at the car. Like I said, this is a 2011 Nissan LEAF. It's in pretty decent shape, but it is pretty high mileage for a LEAF of this age. It's up there, I think it's got a little over 163,000 miles on it. Yeah, and you can see ready is flashing there, and then it went off, and we've got our check EV system warning. It'll close one of the contactors, and then it attempts to pre-charge the high voltage system, but it fails to pre-charge. And there's a few different things that can cause that, which we're going to go over here in a moment. All right, so in any electric vehicle, at least for anything that's a production EV, they have what would be called a pre-charge system. Now this right here is actually the contactor box for a Nissan LEAF that I actually purchased to do the repairs on this car. What you can see here are the two main contactors. So we've got one contactor over here, one contactor over here, and then this in the middle is the pre-charge circuit. So this right here is actually the pre-charge resistor. It's got about 30 ohms of resistance. It varies from manufacturer to manufacturer what they use, but usually it's going to be somewhere in that neighborhood, probably anywhere between, say, 20 and 40 ohms. But for the LEAF, it's a 30 ohm resistor. This is actually the later style contactor box that you would find in a 2013 or newer LEAF battery. And the reason why I got this for this car is because this car actually has had its battery replaced at one point. So it should have this newer style contactor box in it. The older ones are just slightly different. They have a little bit different contactors and stuff, but it's the same principle, the way everything works. But essentially what we have here is this line on one side of the pre-charge resistor goes around and connects right here to the pre-charge relay. So this is just a relay that closes and opens, and when it does the pre-charge, it closes the relay in order to put this resistor in the loop before it closes this contactor right here. I don't remember for sure if this is the positive or the negative contactor. I think it's the positive though. Pretty sure that they do the positive contactor for the pre-charge circuit on these. But essentially you get the negative contactor closing first, so that closes one side of the loop on the high voltage system. But before you close this contactor, you want to pre-charge the system. And the reason why you want to do that is that there's a lot of different components in the car that have a pretty high amount of capacitance because they have capacitors in them. That would be things like the onboard charger, traction inverters, and some other high voltage components as well. So you don't want to just close the two contactors, because otherwise then you'll have a huge inrush of current to charge up those capacitors, and you could damage components. Not to mention you're putting a big kind of shock load on these contactors because they're closing essentially under load, which you'd want to avoid. So what the pre-charge resistor does is it slows down that inrush current because it's limited through this resistor. So you get a slower charge up of all those capacitors over the course of, say a second or two rather than almost instantaneously. And that reduces the potential for damage to the contactors and for other components in the high voltage system. Now there's a few things that can cause a pre-charging issue. both of which are kind of known problems for the Leaf. The first of which would be if the resistor itself is bad. If this resistor is bad, then it can't pre-charge the system to make sure that everything is up to par. And the car is monitoring to make sure that the voltage on this contactor on the output side is up to the level where it needs to be before it'll close this contactor. So that it's actually actively monitoring that to make sure that the car is actually pre-charging properly. If it doesn't pre-charge properly, then the car throws a fault that says there's a pre-charge error and yada yada. But like I said, the problem could be the resistor itself, could be a problem with this relay not closing, or the other thing that it could be is a problem with another component in the car. If you have a high voltage system component that is shorted, basically direct short between positive and negative, it'll never be able to pre-charge in the limited time frame that this thing has to be able to do that. So, or if something were stuck, closed circuit like the cabin heater or something else along those lines. But usually it's going to be a short circuit in a component that would cause that type of failure mode. I actually went through on this car and I checked the high voltage system to make sure that there was no shorted components. The cabin heater, all that stuff seems to be in good order. So it's going to be either the pre-charge resistor itself or the pre-charge relay. We'll find out when we open it up and see. What I'm probably going to end up doing is just likely replace this whole contactor box assembly rather than just replacing the resistor. You can't actually buy the resistor by itself, otherwise I would have. You can really only buy the whole contactor box assembly. Which you can buy them new or used. New, they're absurdly expensive, but you can get used ones pretty cheaply, and these are not typically very prone to problems. But anyway, yeah, that pretty much does it for that. So let's go ahead and get into this thing. We'll drop the battery out, open it up, and find out if our pre-charge resistor is indeed the culprit, as I suspect that it is. Alrighty, so as you can see here, I've got the car up in the air, and I've got the plastic panels from underneath removed. I've also, of course, disconnected the 12-volt battery and the high-voltage disconnect. I mentioned before that the battery in this car had been replaced. The reason I know that is that the case of the battery, as you can see, is black. The original battery on the 2011 and 2012s would have been sort of a light gray color. So the replacement packs are this black color. There's not really a good way for me to know when it was replaced, unless there happens to be like a date sticker on the top. I don't think that there's one on the back side, at least that I noticed anywhere. Yeah, there's just the normal safety warning sticker in the middle there. So unless there's a sticker on the lid, there might not be a good way for me to determine when this was replaced. But I'm guessing probably maybe 2014-ish would be my assumption, just kind of based on the mileage on the car and the condition of the battery. I would guess that this battery pack probably has somewhere between 80 and 100,000 miles on it. It's at about 75% state of health. So given that, I'm guessing that it's probably the sort of second-gen Wolf style battery. That's 2013 and 2014. Although it could be an early Lizard pack potentially. But I suspect that this is probably a Wolf battery. Up here at the front, we can see the differences between this pack and an actual production, a pack that would be fitted to a production 2013 or newer Leaf with the 24 kilowatt hour, and that is that the 2011 and 2012 is missing the PTC heater connector right here. They actually pull that off of a junction box that just is where the main cables here connect. In fact, I believe, actually that is the PTC heater right here, which that's another difference on these cars from the later ones, is they use a liquid-based PTC heater rather than just a PTC heater core in the dash. But I actually took some of this stuff apart when I did the diagnostics, because I did check the PTC heater to make sure it wasn't shorted, which is kind of a known failure that these can suffer from. But in this case, the PTC heater is fine. The traction inverter and all the other stuff up there, DC to DC converter, onboard charger, everything seems good. So that is why we're dropping the pack, is that it's looking like it'll be a pre-charge resistor issue. So I'm going to go ahead and disconnect this stuff here. We've got our data connector, which just twists. I think I've got that off all the way. There we go. And then this one, we'll just pull that tab. I can't really do that one-handed, but I'll go ahead and get this unplugged, and then we'll start actually dropping the pack out of the car. Alrighty, so we've got the battery pack out of the car here. There isn't a sticker from when it was replaced. I can see where there used to be one. There's a little bit of plastic wrap on here. However, I do have the serial number sticker here, which starts with a 16. I've noticed that all the packs that I've pulled out of LEAFs, the first 2 digits of the serial number tends to match the model year or the manufacture date of the car, so I'm assuming this battery was put in 2016. Not 100% certain on that, but that's my suspicion there, which actually makes this pack a bit newer than what I had originally expected. But in any case, the next step is going to be to open the lid up, so we've got to cut through the gasket on the sides. Of course, there's a handful of fasteners to remove. There's actually 5 fasteners on each side, and then we've also got these 6 in the center portion. And you can see we've definitely had some critters running around up here on top of the battery, which isn't too terribly uncommon. But I'm probably going to kind of brush the dust off of this first, just so we can eliminate any mess there. And then we'll go ahead and get this thing opened up. All right, so I've got the battery all cleaned up. All that's left to do is to cut the lid open. So I'm going to go ahead and start on that. And then we can go ahead and check the pre-charge resistor here. All right, so we've got the battery pack opened up here. And right up here at the front in the middle is our contactor box assembly. So you can see we've got the same 2 contactors there with our pre-charge resistor. These 2 connectors right here are actually for the cabin heater on the 2013 Plus. So you can see they literally just use like the 2013 Plus battery, just with a few modifications to eliminate that connector. And of course it's got some slightly different programming on the LBC and stuff. But I'm going to go ahead and pull this bus bar assembly off, and then we'll be able to check the resistance on the pre-charge resistor, or see if maybe there's a welded contactor or something else going on here. All right, we're going to go ahead and work on removing our bus bar assembly here. Technically, this side of the circuit should be dead, but you can't ever be too careful on these. So I've got those undone, and then we just have to unclip this little cover over here. There we go. And we'll go ahead and remove these fasteners. Okay, got these ones over here. I'm just going to break those loose with this, and then I'll spin them off by hand. It's a little bit easier that way. There we go. And then I'm just going to unplug this connector right here as well, because the wires are kind of in my way. Got to unclip that thing though. Grab a tool for that real quick. There we go. That was a little bit tough to get unclipped. Now we can pull this bus assembly off. And now we can check our pre-charge resistor. So we've got that connector right there, and this one right here. And let me grab a multimeter real quick. Alrighty, I'll try and set this. You guys will be able to see it. That ought to do right there. And then I'm just going to connect this between this terminal right here to, oh, lost that. Okay, I'm going to try and keep good contact there, maybe. There we go. And then I'm going to touch this end of the precharge resistor, and I've got nothing. That is open circuit. So we've got infinite resistance there, which indicates that our precharge resistor is indeed bad. So I am going to go ahead and disconnect the other cables and bus bars here, and then I'm just going to swap out the whole contactor box assembly since I already have the whole thing, and then it should be good to go. All right, I'm just going to put a piece of hose on this cable since I'm going to stick it back over here. That should be okay for now. And then I've got to disconnect this connector right here, which I might need the help of a screwdriver to unclip that. There we go. Once again, just breaking the fasteners loose here. Dang, that one's kind of tight. Alrighty, so we should be fully disassembled there. I'm just going to pull this bus bar up out of the way so I don't have to disassemble a bunch more stuff back there. I should be able to just pick this up. Whoa, I'm dropping tools. Anyway, pull the whole tray out. I'll set that to the side. And then we can put our replacement one in. So once again, I'll just pull that bus bar up a little bit. It's lined up into position and drop that back down. I can go ahead and plug this in. And I can go ahead and get our fasteners started. Something funky going on with the threads on that one. Maybe it got cross-threaded when it was assembled at the factory. It doesn't quite feel like the threads are that bad, but they are a little sticky. Okay, we're good there. I can go ahead and bring this terminal back over. Okay, we can go ahead and put our terminal covers back on those. Now for the bus bar assembly here. Alrighty. All that's left is just this connector here. This is actually for our high voltage interlock, so certainly wouldn't work if that wasn't plugged in. If I can just get it back in there. There we go. Make sure everything is assembled and solid. We're all plugged in. Of course, we don't have any connectors here or here for this setup, so I think we're good. All that's left to do is to clean up all the sealant material and put the lid back on, which is starting to get a little bit late in the day here, so I'm probably going to pick back up on this tomorrow morning. Alrighty, so it's the next day. What I'm going to do now is I'm going to just peel off all the adhesive material, both on the pack itself and on the lid. Then we'll put down new adhesive and reinstall the lid on here. So I'm going to go ahead and get started on that, and I'll bring you guys back when I'm ready to put the lid back on. Alrighty, so all of the sealing surfaces are cleaned up. I've put the adhesive down. It's time to go ahead and set the lid back into place on here. So I'll go ahead and pick this up. And I should be able to basically just kind of hold it from the middle here and set it down into position. Just like so. I might need to just give it a little bit of a wiggle here on some of the edges, but I think I've more or less got it lined up. I'll go ahead and get the fasteners for the lid. The four that I've got right here go on the corners, which are kind of the ones that are most important for getting this all lined up. There we go. I think we're just about perfect there. All right, now we can get the ones that go on the sides. And then all that's left is that plate that goes in the middle. All right, there we go. We're fully assembled. Now this thing is ready to go back into the car. Alrighty, it's time to go ahead and get the pack into the car. So I've got it roughly lined up pretty close to where I think it needs to be. I'll probably still have to adjust it a little bit. But we'll go ahead and bring the car down closer to it. Alright, I think I've got all the bolts started, so I'm going to go down just a smidge more. Get the battery into contact. Then we'll go ahead and run all those in. All right, we're fully installed. We can go ahead and bring the car up. All right, back up here at the front, we can get our main cable attached into position. And then our communication cable There we go, we're locked in on that one. And then just got a couple of grounds here to hook up. They're not super critical to getting it running, but I'll go ahead and get those in. Alright, so the battery's fully installed in the car, everything's plugged in. The only thing that's left is to put the bottom covers on. But first, I want to check and see if this thing runs. So we'll go ahead and bring the car down, and we'll get everything reconnected and see where we're at. If I can find the start button, there it is. Alright, sounds like everything's good. We've got green ready, no alerts present. We do have our triangles up there, but that's probably because the door's open and the seatbelt's not buckled in. Let's see what happens if we put it into drive. Look at that, we've got movement. Sweet. Let's see if everything works in here. We'll put on cooling all the way. Make sure our air conditioning works. Feels like it's blowing cold air. My main concerns here that are typical failure modes for these cars are the cabin heater. So next we'll go all the way up to high and make sure the heat works. And then the other thing I want to make sure that it charges, because the onboard chargers on these are kind of prone to failure. I suspect that it does because their only issue, I don't think that they had an issue driving it before it, stopped being able to turn on due to the pre-charge. But we do want to make sure it is indeed going to charge. It might take a while for that to heat up, so I'm just going to let that do its thing for a minute, because it does use a coolant heater, so it takes a little bit for the coolant to actually warm up. Well, I guess I can't plug it in while the car is on, can I? So maybe I will just hold out here for a second. It does feel like it's maybe starting to get a little bit warm. I'll give it another minute. Alright, so it does seem like we're getting warm air out of there. So I'm just going to go to auto, and we'll just set this to a normal temperature, like say 70. And I want to go ahead and turn off. And then we'll plug the car in to make sure that it charges. Conveniently, I've got a level 1 cable right here. So, let's see what we get out of this. Alright, it appears to be charging. I'll let it sit here and charge for just a couple seconds, but it seems like it's doing what it's supposed to do. If it had a problem with the onboard charger, it would have quit by now. So we'll go ahead and unplug, and I guess let's go ahead and get this thing buttoned up, take it for a test drive. Alright, we're just pulling out onto the street here. So far it seems like everything's good. We don't have a B mode because this is an earlier car. We only have Eco. But so far everything seems good. Just trying to feel it out, make sure there's no weird suspension rattles or anything like that. I think that there's a slight clunk when I go on throttle. That might be a motor mount, or it could be a worn CV axle, or even just a nut that's loose on one of the hubs. But so far everything appears to be good here. Heck yeah. Well, I'm just going to finish up my test drive here around the block, and I'll join you guys back at the shop. Alrighty, test drive complete. Everything went pretty well. However, as you'll notice, we do have a flashing airbag light here, which I noticed I didn't mention it because I didn't realize it was there before. So I want to go ahead and check with Leaf Spy and see what's going on there. I also wanted to show kind of the condition of the battery and stuff on this car. So we're going to open up Leaf Spy here. And we're already connected. So here you can see we've got a pretty healthy pack here. Oh, there we go. Now we're connected. It was still stuck on the last pack I had in here. So only about 18 millivolts difference between these, and just a hair under 76% state of health for this. I don't know if I mentioned it before, but when I pulled the battery out and looked at the lid, the serial number started with 16. I've noticed that pretty much all of the packs that I've pulled on any Leafs, usually the first 2 digits of the serial number seem to correspond with the year of the year that the battery was built, or the year of car that it came out of. So I'm guessing that this battery was probably put in 2016. Given that the car has 163,000 miles on it, that probably roughly lines up, since in 2016 this car would have been about 5 years old. Now the car is 14 years old, so that probably means that this battery has roughly 100,000 miles on it. At least somewhere in that neighborhood. So I would say 76% state of health for a 100,000 mile battery. Pretty decent for a Leaf pack. But anyway, so we've got all that stuff here. The next thing that I wanted to take a look at was I want to look and see what our alert is for the airbags. So I'm going to enable the service screen here, and we can actually read DTCs here with the app. Obviously I can do it with my diagnostic tool, but this works pretty good too. And so I've got ABS battery voltage abnormal, ABS high voltage system, CAN-COM circuit. So some of these might be related. The 12 volt battery on this had died while the car was sitting here, so a bunch of these are probably related to the 12 volt battery dying. So let's try and clear some of these DTCs. And in fact, we can even try and clear the airbag fault, although given that it's showing an occupancy sensor fault, I'm going to guess that it might be a problem with the occupancy sensor for the passenger seat here. That is a pretty common problem for these Leafs. So let's see, we'll go back to clear. We'll try and clear the airbag one. Don't have high hopes for that clearing, but yeah, it looks like it stayed on. So that one's probably not going to be clearable, but I think the rest of this stuff we should be able to clear out. It's probably mostly just from the 12 volt battery dying. So I'll just continue to go through all these, clear them all out, and we'll see where we're at once I get through all the different modules. Alrighty, so I went through and cleared all of the different modules. It looks like everything cleared successfully. The only one that consistently comes back is that occupancy sensor, which I'm pretty sure is the passenger seat. I'll have to check into that. But yeah, that's pretty much what does it for the remaining issues on this. Is whatever this occupancy sensor fault is, as well as the little bit of a clunk that I noticed kind of either when accelerating from a stop or transferring between braking and accelerating. There's definitely a bit of a clunk, so that's either going to be CV axle or motor mount. I'll have to look a little bit more into that and see what exactly is going on there. Alrighty folks, that's going to be a wrap for this one. This Nissan LEAF is now successfully back on the road after being completely disabled by that failed pre-charge resistor. Obviously there's still a couple of other issues to address on this. We've got the drivetrain clunk, which isn't that big of a deal, but is something that I'll look into to see what we can do to address that. The bigger thing that's a bit more of a concern is the passenger seat occupancy sensor. Like I mentioned before, that's a pretty common fault on these 2011 and 2012 Leafs, and actually even on later Leafs too. But on the 2013 through 2016, they actually had a recall for the passenger seat occupancy sensor, and for whatever reason, the 2011 and 2012 were not included in that recall. I'm not sure if they use a completely different system for the occupancy sensor mat, or for whatever reason, they just ended up not doing the recall on that, despite it being a well-known issue on these. There's actually a bunch of complaints and stuff on the NHTSA's website about it, but their last investigation looking at that concluded that there wasn't going to be a recall. But that was 6 years ago, so who knows what could happen these days. But as far as what I'm going to do to fix that issue, most likely I'm probably going to end up looking for a used seat out of a wrecked car, or one of these that maybe somebody's parting out. Nissan's only fix for that is to replace the entire passenger seat, which usually costs somewhere around $3,500 to $3,700, which obviously is obscene. That's more than the whole car is worth. As far as next steps for what I want to do with this car, I've got to figure that out. My brother might potentially be interested in this as a commuter. It would certainly save him a lot on fuel compared to driving his 3/4 ton diesel truck. So he might be interested in it. So he's kind of got first dibs. If he ends up deciding that he doesn't want it, though, then I've got to decide what it is that I'm going to do. I'll probably clean it up and likely put it up for sale. But who knows, maybe it could turn into some kind of a crazy project to do something with. In any case, the repairs for this video are complete. And if you like seeing more stuff like this, make sure to stay tuned in the future. And as always, thanks for watching.